All right, welcome back. Now, we've gotten into a part of the material that I happen to like and like a lot. This is control groups. And it gives me the ability at the operating system level to restrict the amount of hardware consumables that a particular process can use. All right. Now, it says it's 70 minutes for the lecture. No, it'll be probably 40 to 45. All right, so it'll be about 20 minutes less. The practice is 25, and I will agree with that. And while I may not have had you interested in doing the LDAP, you need to complete the control groups practice. All right, that's a requirement. Now, in Oracle Linux 7, control groups are now under the control of systemd. And so while there was at one time a C group directory, that full directory structure with all of the subsystems that are associated with control groups are now moved under /proc. All right, so that there's a considerable amount of difference, but it's now tied hand in glove with systemd, which I think is good. All right. From Oracle Linux 6 to Linux 7, we've added 2 more subsystems. All right. And when you look at them, they kind of make sense. We'll do that in a couple of pages. Even in 6, I like control groups. If you are using the Oracle database, then there is a DBMS resource management package where they try to control consumables inside the database. I'm not so sure that that works well. But to use C groups and control them at the operating system level, instead of trying to control it at the application level, makes much more sense to me. All right. And you know, when you look at Oracle Linux, the first Unbreakable Enterprise kernel came out at 2.6.32. C groups have been around since 2.6.20 or 2.6.22. And so they've been around since 2010 or earlier. Okay. Those are all good things. All good things. And I'm not here to give you a history lesson. But to look back over time and see where we've come makes good sense. So it's a hierarchical model, and it comes with a default hierarchy, and you can change it. In other words, however you want to allocate your resources, you can set up a hierarchy to do that. Which cores do you want to use? How much time per core do you want the processes to have? How much memory do you want them to have? All of these make good sense. Now, to give you an advance, the next lesson we're going to do is on Docker. Small, lightweight containers. Docker uses C groups. That's how important C groups are. And I don't mean to diminish Docker at all. Docker is very, very important. Okay. So, moving down, systemd, service unit, or slice units, and scope units. All right. And those slice and scope are set up about what is currently executing. All right, because we're going to have user slices, but it's only for the users who are active at that particular time. There is a CG list utility. No, don't ask why it's not CTL. All right. Once again, a different development team was not aware of the current convention. We can take a look at the C group tree for specific services and scopes. We can display a myriad of system resource control settings. We can control access to system resources, which is what C groups is all about. We can modify the unit configuration files for the hierarchy that you define, and there is a systemd run utility that gets used as well. C groups, control groups, enable you to allocate computing resources. Let's pretend you're on an 8-way box. And so you've got cores 0 through 7. Well, let's build 2 imaginary C groups, one of which uses the even-numbered cores, 0, 2, 4, and 6, and a second odd-numbered C group that uses 1, 3, 5, 7. Now, I picked an easy example, all right? Yes, I'm fully aware that you could have 64, 128, even 256 cores. I mean, that's not out of expectation. I've been around the Oracle database since the early 90s. And if we had performance problems in the early 90s, the joke was add more memory. Even in a 32-bit environment, not everybody had 4 gig 25 years ago. Today, people have more memory than they know what to do with. And so, if there's a performance problem, the answer is add more cores. And any one of the multiple Intel CPU vendors are more than welcome to have you add more cores. Not hard at all. So we can parcel out the cores. We can then take a relative share of the CPU time. So out of every 3 minutes, you only get to use 2 of them. Or maybe out of every 6 minutes, you only get to use 5 of them. So you then, even though you're limited in the number of cores, you're limited in the amount of CPU time that you can actually consume. Okay? Now, we can put memory limits on the tasks that are in the C group. Your box has got 128 gig. No, not everybody gets that 128 gig. And so you can assign a memory limit to a C group. All right? Nice thing is, if you have a runaway task, it's going to come to a point where it can no longer do a malloc. All right? Just can't. Then within the subsystems, and we'll see them on the next page or a couple of pages after, we can also report CPU time and memory used by your C group task and get it by process ID, get it by task. And you can then deny or allow task in a C group access to specific devices. You've got a lot of control. That's why I like it. And more importantly, it works. The DBMS resource management was beta in 8174. It was beta in 8174, and it didn't work. 9IR1 came out. It didn't work. 9IR2 came out. It still didn't work. It was not until 9IR2 202 that it actually worked. All right. So a dual name for C group subsystem or kernel resource controller represents a single kernel resource such as memory or CPU cores or cycles on CPUs. And the C group associates a group of processes or tasks with a set of parameters, a set of restrictions. We have 10 subsystems, all right? Block I/O, BLK-IO, CPU, CPU account, does reporting, CPU set individual cores, devices, freezer. Freezer will become important next lesson when we talk about Docker. We also, not in this lecture segment, but we now also have something called Linux containers. And so another approach to virtualization that doesn't require a hypervisor, which is kind of what Docker does. We'll save that for the Docker lecture. Memory reports or limits memory use. And then netcls tags outgoing network packages with an identifier. You know, you got to draw the line somewhere. And so those 8 were the subsystems that were in Oracle Linux 6. And so what's been added new here in Linux 7 is the performance event, perf event, and there's now a perf tool that supports it. And because you've got way more memory than 4.3 gig that you would have had in your 32-bit environment, oftentimes you'll enable huge pages. And so we now have a huge table, and it allows larger page sizes than the 4K default size for memory addressability. All right. 4K goes to a low end of 2 meg, and then there's a high end of 256 meg. Okay. And trust me, you know, if I've got 128 gig, or what if you're on an engineered product from Oracle? You know, one of those Exadata machines. God love it. 2 terabytes of real memory. Oh my God. Had you offered me 2 terabytes 25 years ago, I probably would have said, what's a terabyte? You know? And yet today we have engineered products that do that. So yes, we need huge table. And that's why I'm saying these new additions in 7, at least to me, given Oracle's engineered products, make a lot of sense. So here, cat proc C groups gets you data about the C groups. And then the list subsystem command allows you to list the subsystems that are there. Now, one of these is different. This is where you have built your own hierarchy. And you've included CPU and CPU account. Okay? And so, just to refresh you, CPU provides CPU access to CG groups. CPU account reports on CPU resource usage. So that kind of makes sense, all right? And to tie those two together, that fits very, very well. Moving down the list, memory devices, you can limit devices. C groups themselves, the freezer concept is in a container, I can freeze, pause, the container, or I can unfreeze it. So it's not a C group thing, but it's a convention for containers like the next lecture on Docker. All right, and those are really lightweight containers, have much less of a footprint. That's a pretty exciting lecture, but I don't want to give it all away, all right? So I'll stop talking about it. The netcls, the block I/O, perf events, and huge tables. So it's not hard for you to build your own hierarchy. And then when you do the list subsystem command, it shows you what that hierarchy is. Oh my God. There are a list of parameters. And we'll show you some of those here on the next couple of pages. Honestly, we literally just scratched the surface. I have what? A 45-minute, 50-minute lecture here. I would need a couple of hours to get through all of the settings. All right. So we'll give you some insight into the ones that are most commonly used, and certainly we'll show you how to go look at all of the ones that are there. So subsystem parameters allow you to actually set those limits, restrict that access, or define allocations. What cores do you get? Understanding the specific parameters helps you to understand the possibilities. And I would tell you, you may have to do some experimentation to get everything figured out. Now, once that C group is built, if we're not talking about containers, then what you have are process IDs, PIDs. And so pretend PID 24 is HTTPD. Apache. Now, I will apologize once. Yes, I've used Apache. It's good. However, with Oracle, if you're doing a web server, you're probably not using Apache, nor are you using Tomcat, but you're probably using WLS, WebLogic Server, from Oracle. So I can take a process ID, a task. The task file keeps track of processes associated with the C group and associated subsystem parameter settings. Now, every time you reboot the box, HTTPD may not get the same process ID. And so we'll show you ways of how to identify by daemon which C group that daemon goes to. All right? That way you don't have to track a bunch of process IDs. In Oracle Linux 6, the C group mechanism was optional. As you look down here at the last bullet, C groups are now an integral part of System D. And so while in 6 we had a live C group, we had a directory in root called C group. In etc there was a cgconfig.conf and cgcreate, cgdelete, cgget, cgset, all those sorts of things. Now, systemctl, as we've talked about before, this is the tool that is used to modify the system unit files for C groups. Okay? The only exception is the net priority resource controller. That falls under net_CLS. Now, you have the flexibility to change the hierarchy. And so in the previous example, we built this new hierarchy. CPU and CPU account are now put into CPU, CPU account. All right? And notice that those are links, and that here is the actual directory where the CPU and CPU account are stored. And so we take CPU and CPU account, and as links, we point them to that directory, CPU, comma, CPU account. Set devices, huge table, memory, netcls, perf event, and a new directory that was not there before, and that's the systemd directory. Once again, control groups are all inside of systemd. Now, I would like to escape this page to give you an idea of some of the parameters. So here, we've taken sysfs cgroup block IO. And some of the parameters here are block IO, IO merged, IO queued, throttle IO service bytes, throttle IO serviced. And notice there's a lot of ellipses. Once again, there are hundreds. Certainly 700 or 800. I don't think there's 1,000 yet. Haven't really gone back and counted them recently. All right. So under that CPU account, we have CPU shares, runtime period, US, runtime US, use, stat, account stat, CPU account usage, and once again, there are a lot of ellipses. And so this is literally just barely scratching the surface. Here under CPU set, we have CPUs, CPU set MEMS, CPU exclusive. So maybe I have a special C group and I have a set of CPUs that are reserved just for that C group. They can't even be shared. Devices, allow, deny, list. Freezer. Now once again, we've got to be working with containers. And the freezer state is running or frozen. And you can unfreeze a frozen container. Huge table. Notice that the huge table, 2 megs, remember that number I gave you earlier? Failed count, 2 megs limit in bytes, all right? And once again, based upon your memory, that huge table can grow to 256 meg, all right? Memory, limit in bytes, absolute. Soft limit in bytes. Give people a warning that they're approaching the upper limit. netcls, class ID for that particular net activity. Perf events. Now, the UEK doc here, user shared doc, kernel doc version, documentation C groups. And so there's an index, and then there is CPU sets text and memory text. There's something called, I can't do this because I'm on the notes pages. I'm not on the slide. My bad. The 3-letter acronym is L as in Larry, S as in Sam, B as in Bob, LSB. In Linux, this is the Linux standard base. Now, I consider myself a fairly good programmer, a DBA, and a Linux system admin. But there are people whose career centers around being a technical writer. And those folks that are technical writer working for the LSB Foundation do excellent documentation. All right, that they live to do documentation. Probably would not be a career choice that I would make. Just probably wouldn't. So, as you look in the very last directory, systemd, we have slice, scope, and service. And so under the system slice, you will get a listing of all of the services that are running on your box. In the user slice, every user has a user ID number. And so you'll have a user-1000.slice. And it contains the current processes that run as scopes in the transient C groups. And so I could be doing the /bin/clean and clear command. Or under the secure bin directory, I could be doing SSHD, connecting to another remote server. And once again, others that are down there at the bottom. Now, you won't have a user slice unless when you do a hu-r command that the users actually showed up as being logged on. So in the systemd slice unit, a slice is a concept for hierarchically managing resources of a group of processes. For each slice, certain resource limits, parameters, can be set that apply to all processes and all units contained in that slice. Slices do not contain processes, they organize the hierarchy. Actual processes themselves are maintained in the scopes or in the services section later on. So, --slice is the root slice. There's a system slice, there's a user slice containing all user sessions currently logged on. There's a machine slice that contains all of the virtual machines and Linux and Docker containers. Scope units are similar to service units in that they both encapsulate processes. Service unit processes are started by systemd based upon the service unit configuration files. Remember, you take systemctl and you enable a service. Next time the box boots, systemd starts that service. Scope unit processes are started by arbitrary processes via a fork. And so if you ever look, you might have 5 or 6 HTTPD processes running, and all of those are started via a fork, okay? And as they get started, they're registered with systemd as they are forked. All right, that's what that's all about. The main purpose for system units is grouping worker processes for managing system resources, which it does very, very well. User sessions, VMs, and Linux and Docker containers are all treated as scopes. So we're about halfway through this set of material. What I'd like you to do is to take a momentary break. We'll come right back and finish the lesson. Thank you for your attention. All right, welcome back. We still have a few pages left in this lesson. And so the reason that I broke where I broke, this is a new command, systemd control groups list, systemd-cgls. And you can display the slice and group hierarchy. All right. And so obviously the number one process is systemd. And then there's a user slice, and within the user slice, there's user 1000. I used that as an example earlier. Slice, and the session 3 scope. Then there's a system slice, all right? And so because we're looking at a user who has connected, then that connection, that user scope slice, or that user slice, gets automatically created when they get logged on, and then when they log off, it goes away. And so as you do the practice, once again, I would encourage you here for C groups to very much do the practice, that this is worthwhile. Once again, I'm not so sure that the LDAP was, but if you did it, congratulations. All right? And so we have problems in that folks open one window and then they sign off. And so what you got to do is you got to have a couple of different windows open, one running one series of commands and one running the systemd-cgls command as root. Okay? And you notice slices do not contain processes of their own, with the one exception of systemd. Now, there is, under systemctl, status. And we can display the C group tree for specific services and scopes. And so the first command is a status for the secure shell daemon service. Makes your server something that you can SSH to. All right. Then there is a status for session 3 scope. And so the C group, user slice, user 1000 slice, session 3 scope. And then there's a whole bunch of other things under that. And that came from here. And you notice the ellipses that are here actually get shown in this section down here. And there are other things. In run level 5, the GNOME Display Manager, DDM, session worker, and notice that my good friend pluggable authentication modules, GDM password. There's also a GNOME keyring daemon, all right, that help manage that environment. Tell you what, let's look at the back page of this. Let me escape the page. So here is the status session 3 scope. And notice once again there are ellipses in many places, okay? And so as you scroll down the list here, I may have signed on as Oracle, but I did a substitute user dash to root, and then what that new root session is running is bash. I mean, that's all pretty common. Okay, and so we can track what happened in session 3, because that's specifically what we're looking at. Okay. Oops. Yeah, I'm through. All right. Here, system CTL show SSHD, let's grep -i CPU. and we get CPU accounting, CPU shares, all right? And once again, that 1024 number, as I recall, is the default. It's not something that you configured, okay? But the notion is you could reset it, all right? And we'll show you how. The next one, systemctl show user 1000 slice, and let's grep-i for memory. And so memory accounting is no, but the memory limit is huge. And so once again, there is a man page here, systemd resource control, all right, that will provide you all of the information about how to go in and limit these. You may have a lot of storage available, but you may not want to let Oracle, that user ID, handle all of it. Remember, what Oracle really looks at is the amount of workspace for the SGA and the amount of workspace for the PGAs. And so even though I have 128 gig box, or even 2 terabytes, the total database footprint in the memory on that box may be under 100 gig. All right, that's not uncommon. Here, systemctl set property to change those resource controls. So if you recall, where we were 1024 on the previous page, we're now only 512. And you can do that set to bring that property down. And there ought to be a get property command as well. So I can say get property SSHD service. Now, what happens is you'll get a whole lot of other things, which is why on the previous pages we were doing a grep to filter out just what we wanted. But if you want to look at it all, you can look at it all. You might want to pipe it into less, all right? And so here, once we have done this new set command, we have the CPU shares now at 512. So all this information is stored in files. The real files, user, lib, systemd, system, and you copy them from there over to etc systemd system. We did that back in the lesson on booting. You made the change in the etc systemd system directory, and then in this case it's either a daemon reload because it's controlled by systemd, or you'd go back out and you'd restart just that service. All right. And so with there being systemd at the top of the heap here, you know, hierarchically, so you're going to do a daemon reload, which reloads systemd, and then restart the specific service to get those new pieces, okay? Lastly, there's a system run command. And the intent with system run is to run a particular program in a transient scope or service unit. When the run in a service unit, the command runs in a clean execution environment. Systemd run starts the service asynchronously in the background and immediately returns. When run in a scope unit, the command inherits the execution environment from the systemd run. Execution is not asynchronous, but is synchronous. and returns only when the command finishes. And so I can do a systemd run for a unit name, a scope, create a scope unit instead of a service unit, or a slice. All of those sorts of things are available through that systemd. And once again, we'll give you an example as we work down through the practice. All right, I think we're done here. Quizzes. C groups, enable you to do which of the following? Specify the relative share of CPU time available. Specify memory limits. Freeze a task, suspend it in a container. Or report the CPU and memory used by the task in the C group. What I really think we need down here is we need a letter E for all of the above. Now, I'm pretty sure that's not what the key gives us. No, C doesn't have an E, but it does have A, B, C, D. As Paul Harvey would say, page 2. Which of the following statements are true? Systemd service automatically mounts hierarchies for kernel resource controllers in the C group directory. Not. C group was 6, not 7. The system slice directory contains services and other system processes? Possibly. The user slice directory is the top level directory for all currently running user sessions. And slices do not contain processes, they organize the hierarchy. I think we'll find that BCD are the correct answers here. Now, I'm an old COBOLer. BCD, to me, is binary coded decimal. And it was a data format for a number. And you do numeric calculations with it back in the COBOL days. Easily 40 years ago. All right. But I'm not that old. I was 6 when I started. Lastly, which one of the following commands allow you to run a program in a transient mode or service unit? The key word here, can I get it? No, is the word run. Does that give you a hint for the command? And the answer is, well, yeah, Al, that ought to be D, systemd run. Yep, that was kind of a dead giveaway. Craig does that occasionally. All right, the summary here, we learned the purposes of control groups. Al thinks they're important. We introduced you to the 10 subsystems and a very, very few of the parameters. We talked about the differences between Oracle Linux 6 and Linux 7. And we described how you, as root, can go out and change the C group hierarchy model. We talked about slices, units, scope units. All right. We took the CLS list utility. We took a look at the C group tree, system resource control settings, access to system resources, and unit configuration files. And then lastly, we touched on the systemd run utility. So we're going to explore C groups and the way they have been integrated into systemd. We'll explore C group hierarchies and C group subsystem parameters, controlling access to system resources. This lab is worthy of your attention. All right. This is practices for control groups. All right. And as we look at what this is going to entail, we have exploring control group integration into systemd, exploring control group hierarchies and C group subsystems, and then controlling access to system resources. All part of what control groups should be doing, all right? And so those three lessons, 11.1, 11.2, and 11.3, all coincide with the practices here in the overview for practices number 11 on C groups. And so you are the root user. You're on host 02. It doesn't make any mention to being connected with VNC Viewer. All right. And we're going to take a look at the sysfs at /sys/fsc group systemd directory. And it contains a hierarchy of slice, scope, and service unit for the C group tree. Okay. So once again, here I'm here connected to host 02. Once again from the last practice. All right. Let's do a clear. And so the root home directory, and once again I'm on host 02, seems to meet the requirements of the assumption. And so a CD to sysfsc group systemd CD sys fs C group systemd. Oh, dash K. How about that's right next to the L. Now I do find the C group event control, which only has write privileges, okay, unless you have some special software, you can't write things that you can't read. Now, that's kind of how it works. Come here, cursor. There we go. And so we have a directory here for system slice. And as we look at system slice, there are a lot of other directories here. And so let's start ls -l system slice pipe wc-l, and so there's 90 of them. All right. Now once again, as they get listed here, all right, and there's going to be a lot of them. Tell you what, let's take and pipe this potentially into less. I mean, that seems to make a little bit of sense to me. All right. And the thing with this, you get the chance to see what's here. And so we've got about 24 to a page, so there's probably 4 pages, 2 pages, 3 pages, 4 pages, 5. So maybe I'm not getting 24 pages, I may be only getting 20. But certainly we started with the abort CCP service, and now we have the WPA supplicant service. And so that pretty much sums it up, all right? And most of what here are directories. The one example that is not is the task file, all right? So a queue here. And once again, that file's got 0 bytes. So once again, the expectation that there would be something there, it's not. Okay. So that is system slice. The next part I think we're going to look at here is user slice. And once again, that ought to be much more modest, all right? And it is, all right? Once again, there's that clone event control, clone procs, notify on release, and then task, all right? Once again, and as you look at those files, they're all 0 files, okay? And then the user 1000 slice obviously is the connection back here to the Tiger VNC to host 02. And so if we go take a look now at the user slice directory for user 1000, and so once again, what we're looking for is that session 8 scope, okay? Now, in the book, I think it gives a different number. Oh, it gives it 16. Your number may be different, all right? So don't believe the 16. Certainly don't believe the 8. That is on mine. I guess your mileage will vary, okay? It's probably the best answer for that. And so there's clone children again, event control, C group, procs, notify on release, and task. All right, and so obviously we're taking a look now at this working directory, and then user slice, user 1000 slice, and then session some number for scope. All right, and once again, there's a real good chance that your number will vary, okay? If we took systemd slice units, then what we want to do is we want to look for file names that have a slice extension, all right? And the -t type is a slice, and the -a command to list all loaded slices. Once again, you'll notice down here by the ellipses that this is obviously not a full page representation. Well, we didn't take that many more pages, all right? And so as I showed you during the lecture, dash period slice, all right, and it's labeled as the root slice, which is okay. There's a TTY slice, an LVM2 slice, okay, X2 DPV scan slice, system slice, user 0 slice, user 1000 slice, and just a user slice. And so once again, user 0 is root, and user 1000 is Oracle. Now, as we take a look at the systemctl-t slice all, we're going to do a find from root name and surprise, surprise, some of those names look very similar, all right? The order may be a little different, all right? But some of the names are very, very similar, okay? And obviously the find command goes into, once again, subdirectories as it traverses. And that was that slice command. And so scope units, and so we're going to bring that same command up that we looked at for slice just a moment ago. We're going to take a look for scope. Now, there's a session 301, all right, session 301 of user root, session 8 of user Oracle. So it actually tells you that it's Oracle. Now, once again, what you see in your lab guide will be for scope 16, and once again, your scope may vary, and that 301 scope, once again, it is not necessarily the scope associated with root. Depends how often that host 02 has been up and down. And so we're going to do the same thing for scope. And once again, the expectation is that we find some of the exact same kind of files. And so we found the 301, the 8, and now there's a new session-2 for scope. All right. And then the user 0 and the user 1000 tied back to the 301 and the 8. Once again, your mileage may be different. All right, just so you know. All right. C group list, kind of like cspot run, okay? C group list, okay? It might help if I put a D in that word. What do you think? Amazing how much better it works. Now look at the graphic. All right. Now, process ID 1, which is actually systemd, runs Linux 7. Okay. No, it's no longer called a NIT like it was in Linux 6. And so then under the user slice, user 0 slice, session 301, and then here is the CGLS command, the SSHD command, because I've got this window open where I connected with Secure Shell. And then for session 8, which we now know to be Oracle. All right. Now there are some other pieces and parts here. First 23 lines, 46 lines. Now we go back to the system slice. And so the systemd.journald service, remember that's where the journal goes, all right? And package kit, once again, I'm not really a fan of that. There we go, all the way down to 153. We'll do a Q to get out. Explore systemd service units. And we're going to pick on what was the very first one up here, the ABRTD, which is an abort process. All right. And look at what the portions of that system slice are. Okay. And so we're in system FSC group, systemd, system slice abort service. And so back here, clear PWD, so sysfsc group systemd ls-l system slice and so once again we have some of the same files in the various different services that are repeaters. Because once again, you've got some of that same information for all services, for each individual service. Now, the task file records the process IDs of the process associated with the service, and in turn with the C group and the associated subsystem parameter. And so as we look at this, our expectation is that there may be something in this task file. All right? Because when we looked at it a moment ago, it was 0. So no, I don't think there's anything in it. I think that's going to come back and give us the empty set. Which it did give me a PID. So why does it not? Oh, that's right. At the time the file was created, it had nothing in it. Okay. A PS-EF pipe grep for 2957. And surprise, surprise, that is the abort D daemon. Okay. Once again, there is a very high possibility that your number could be different. All right, just so you know. Oh, they did the grep just like I did. That makes sense to me. It's amazing what happens. Status of abort D. Obviously, it's loaded and active. I have notes that tell me that sometimes we actually shut down abort D because it can be a hog. I probably didn't say that PC enough. I'm sorry. All right. There we go. And it's active and running, and it's the same 2957 as we actually saw from the file. Okay. Now the next task that we want to go after here is the SSHD service. All right. And so we'll just bring up that cat command, use a different service name. All righty. And obviously root is connected through that SSHD daemon. So the daemon's running, but the daemon also has one connection. All right. So it's not only up and running, but it's in use. And once again, it's active and running. All right, and those are the same 3 commands that were up here. And once again, the numbers all vary, folks. And so your expectation should be that, yes, we'll have the same processes, but no, they won't necessarily have the same process ID numbers. The PIDs will be different. And so SSHD cron D, status of cron D, and that's all up and running. All righty. Now, what we're going to do is we're going to switch directories on you. Previously, we've been looking at the sysfs, which is mounted on /sys/fs, but also part of the init RAM disk, part of the virtual file system is /proc. And so in this particular 11.2, we're going to take a look at the C group subsystem parameters and the C group hierarchies as represented inside of the /proc directory. And so the output here should be very similar to the lecture content that we saw for this material just a moment ago. And we're going to take a look here at what we have as part of this hierarchy, and then what we're going to take a look at is the actual C group directory over in the sysfs. All right, so there are the 11 lines of output, if you will. The subsystem names, CPU set, CPU account, memory devices, freezer, net, CLS, and block IO, Linux 6. Linux 7 adds, perfevent, and huge table. Alrighty. Now the next command was an ls on sysfs C group. It was an ls-l. And so once again, obviously the blue are directories. The links are that cyan or turquoise or blue-green color, depending on what it looks like to you. All right. And that actually creates a different hierarchy, all right, than those 2 individual subsystems. All right, so that's the C group. And so now we want to do a mount command and pipe that into grep, looking just for the C group information that is there. Mount pipe grep C group. Now, I guess that could be a little wider, couldn't it? Oh, it got a little better. And once again, I could maybe, I can't get it all, I don't think. Well, that's okay. Once again, there's a lot of C group there. And most of it is now all on the same page. Are all on the same line. It's always been on the same page. Okay. So there is documentation here. And once again, we showed you this documentation during the lecture component. Okay. So we're going to actually go chain to this directory. We're going to do a cat on double index. And so I'm a little, once again, reluctant to use the cat command, but I'll certainly use less, all right? And so this file, we have the block IO controller, C group event listener, and then there's just a whole bunch of other detail here with regards to things that you can get. And once again, there's 900 lines, or 900 bytes. So I got 2 full pages worth of output. Okay, once again, I'm a big fan of less. So I believe the very first thing here in the line is the block controller. Okay, and so going back here, ls sysfs C group block IO, and then there are just a whole series of files in this directory. And once again, there'll be a lot. Alrighty. And so ls sysfs C group block IO. And each one of those is a parameter, all right? And if we were to cat one of those files, then there would be a lot of numbers or activities or settings within that. And in the directory that we're in, a less the text file here, block IO controller, the subsystem block IO implements the block IO controller. There seems to be a need for various kinds of IO control policies. All right. And so once again, this starts it out. There's an abundance, a wealth of documentation here. Once again, I'm not going to page down through it all. I'll do a quit and get out. If we come here to CPU set, once again, there are parameters, okay? And there is a and once again, a very, very large bulk of information already. And so once again, with a very brief lecture, and then not that long of a practice, folks, you're going to need additional documentation to really get your arms wrapped around control groups. Okay, I'll do a Q and get out. Okay, we want to do C group now memory. We did block IO, controller. We then did CPU set, CPU set text, CPU memory. All right, we picked memory limit in bytes and usage in bytes. And then there is this memory text file as well. All right. And so down here are the various control files and settings. All right. And so each one of these are a file, and it has the numbers or the details that correspond to that particular entry. And then we've gone and done 3 of these in a row. What they'd like you to do is they'd like you to take and go through and continue to view each individual subsystem. No, I'm not going to give you guidance on that, all right? You're adults. I believe it, once having seen it 3 times, you ought to, and already having those 3 commands keyed in, you ought to be able to bring those commands up, make some modifications, and get some additional output. We're going to look at the properties of a systemd service unit. The one that we're doing here is SSHD, but we also did cronD, we did abortD, all right? And those are all services. And so here we're just going to do a show. Type is simple, restart on failure. It is a system slice, which we would expect for the service. And the control group is system slice SSHD service. All right, so that would be our expectation here. And there is CPU account, CPU shares, block IO accounting, block IO wait, memory accounting, blah, blah, blah. I mean, there's a lot of stuff here. So we'll go back here, do a Q to get out. Let's do a clear. And so simple, restart on failure. Those were the first lines, and then there were some ellipses. All right. Page 1, 2, 3, 4, 5, 6, 7. So there's 143 lines of output that help control this SSHD service. All right. There is a bug in the systemctl show command in this version of Oracle Linux. Some of the resource control default values appear as 1844.6, which equates to 0 Fox FFFFF. It's a feature. All right, so if we go search for the 1844.68, And so once again, it occurs several times. It's one of them undocumented features. So you can view the default resource control values under the sysfs cgroup hierarchy. Okay. And so here we'll do a list for CPU shares. And we have CPU account with CPU shares, and then CPU with CPU.shares. And a grep of CPU shares gives me that information that we would see from it. All right, and once again, there is a man page, okay, that's associated with the resource controller. So let's start here. And so I'm all the way bedded down deep. So let's go cd sysfs cgroup. And then we'll do an ls star. And so we found the exact same ones that were there. And if we do for a single period, then we get the information out here with the numbers that you see that are appropriate and the entries in the file that actually have sort of a purplish look to them. All right. No. And so we have this CPU weight, and once again and the entry there is 1,000. And so what can all these files will have some sort of information, some sort of data in them. Okay. And so as we take a look at sysfs cgroup, and we look particularly in CPU and CPU accounting, the files that are here are the files that are listed. Okay. Okay. And so change the CPU shares property from the default of 1024 to 512, and change the CPU accounting property to true for the SSHD service. Okay. And so the systemctl set property SSHD service CPU shares to be 512, CPU accounting to now be true. Okay. And so there are now two new directories, the user slice and the system slice. Those directories were not there before, all right? And they have in them these numbers that we just changed, all right? And so if we took the system slice and did an ls-l, then there is, once again, a whole lot of numbers tell you what, let's pipe this into grep for SSHD. There we go. How about an SSHD service? Is that a lot easier to pick that one out instead of looking at all of them? Yeah. Once again, all you gotta do is add a little bit of smarts to it. All right, that's it. So this is in the system slice. And so if we go out and get it, here are the files that are there, okay? And so the two files that we had were CPU shares, there we are. We want to do a cat on that. And it's, surprise, surprise, 512, just precisely what I set it to. If we take a look at task here, no, I must be in a different directory. Oh yeah, I am. All right. Oh, how about an S on the file? There we go. That's that same 35 or 38, 35 that we saw earlier. PS-EF pipe grep 38, 35. And there's that SSHD -D for the daemon. And then my root connection down there at the third line. Okay. So if we go in here and do a show property, CPU shares -P, CPU accounting for SSHD, our expectation would be to find the two things that we changed. Okay. And once again, those are the settings that we made earlier. So the notion is here that anything can be adjusted. Once again, there is just oodles and gobs. That's a technical term now, oodles and gobs of documentation. Okay. It used the set property command to change the value of memory subsystem parameter for the SSHD service. Before setting the memory, let's use the ls command to view the contents of the sysfs cgroup memory system slice SSHD service. Okay. And so this particular command cannot access. All right, there is no such file or directory. Before we can set it, the directory does not exist. Change the memory limit property to 1 gig. Change the memory accounting property to true for the SSHD service. And then when you go back, there's a directory there that wasn't there before. And once again, sysfs cgroup memory system slice system service not there. Okay. And so we want to do a set property for SSHD. Cool. And there you go. Done. And so once again, it helps populate the infrastructure as you make changes. And so once again, it's not going to put something out there that is not necessarily useful, but as it becomes useful, then fully expect it to be there. Okay. That look about right? Oh, I need another dash P. And so now it's 1 gig and it's yes. All right, so we've now been able to make that change. And once again, the change occurs obviously in real time. All right, so here, if we go actually cat sysfs memory system slice systemd service memory.limit in bytes, we're going to get out that 1 gig. Okay. Limit in bytes, cool. And there you go. And so once again, you make changes. The changes are effective in real time. The changes are effective immediately. Okay. And then that's that 3835 number that we've seen a couple of times today. All right, and once again, that's not the number that's in the book, and I'm pretty sure it's not going to be your number either. All right, just so you know. All right, we can define resource control settings for the cron-d service in a unit configuration file. In addition to changing the resource control settings with the systemctl command, you can define resource control settings in the unit configuration file. So let's take the cp command to copy cron.service from user lib systemd system and put it in etc systemd. The files in user lib systemd system are provided by the install RPM, and you should not edit them manually. No, you just shouldn't. So let's take the user lib systemd system cron service and copy it over to systemd. Okay. Let's cd to home. And so under the service area, we're going to add some additional lines. So I'm going to do an O to open a line. All right, so we're changing the memory limit to 500 meg. I would probably make that 512 if it was myself, because it had been potentially a gig. Okay, and so 512 would be a half a gig, but I'm not going to pick nits here. All righty. So escape :WQ. Alrighty. systemctl show cron_d pipe grep ignore case memory. It's going to see a counting no and memory a huge number. All right. And so the no and the large number. And so we'll take the systemctl command. DAEM daemon reload. Restart cron_d. Memory. Ah. What do you think? Think it might be misspelled just a touch? Arrgh. There we go. It's amazing what happens when you type it correctly. You know, it's all in the typing. Okay. All right, so we restarted cron_d. It would probably have a new process ID. Cool. Oh, keep the same process ID. Okay. Once again, your mileage may vary. Okay. Ah, that's because it's systemd, it's not cron_d. Yo, much different number. All right. So ps-ef pipe grep 10796, and that's cron_d. All right, that would be my expectations. Oh, and that's it. All right.